Hi, everyone. My name's Andrea, and I'm a content marketing specialist here at Vultr. In today's Tech Talk, we're proud to unveil our Vultr GPU stack and container registry, which is a comprehensive solution designed to empower enterprises and startups worldwide to build, test, and operationalize AI and machine learning models at scale. Watch the Tech Talk now.
Hi everyone, my name is Mayank and I'm the head of developer advocacy here at Vultr. And in this tech talk, I'm going to introduce you to the Vultr Container Registry and the Vultr GPU stack, simplifying DevOps and AI ML development. Vultr Container Registry plugs directly into Docker and Kubernetes. It allows you to store your containerized applications and container images on our infrastructure closer to your other cloud resources such as VKE clusters, your virtual or bare metal instances. It supports both public and private repositories, and you can have unlimited repositories per registry. You can securely upload your container images over HTTPS, and it is absolutely free to use for a single registry up to 10 gigabytes. Moving forward towards Vultr GPU stack, it is an image based on Ubuntu which comes with reliable and tested pre-installed softwares which can eliminate a lot of your setup time for each AI and ML testing instance that you deploy. It comes with NVIDIA drivers, NVIDIA CUDA toolkit, the container toolkit, CUDNN, and also deep learning frameworks such as PyTorch, TensorFlow, topped up with pre-installed Jupyter Lab for importing all of your existing Jupyter notebooks. It is available for both virtual and bare metal instances. You can also combine both of these products together to create a machine learning deployment pipeline by pulling an open source machine learning model from a public container registry, fine tuning it, sending it back to a private container registry, and then you can spawn up as many inference nodes as you want in any of our 32 data center locations with convenience of container images and also the scalability that it provides. So now we can jump on to the demonstration of spawning a virtual GPU stack instance and also how to use the virtual container registry. So to get started, let's see how to deploy a new server with the Vultr GPU stack image. To do that, log into your Vultr customer portal and navigate to the products page. Here on compute, you can hover over this blue button and click on deploy new server. Then we can select cloud GPU, select the type of GPUs that you want, select the server location, and here is where you have to find Vultr GPU stack by clicking on operating system and then opting for Vultr GPU stack. Here you will see options of both the Ubuntu images. We'll go with the latest one. Then you can select the server size. I'll go with 4 GB option. And then you can opt for the additional features such as enabling IPv6, DDoS protection, and also auto backups. Then you can deploy the server by clicking on this big deploy now button. Meanwhile, I have already deployed a server with Vultr GPU stack, which we will be using in this demonstration. You can go to the instance page. Since Vultr GPU stack comes with pre-installed Jupyter Lab environment, we can just copy the IP and open a new tab, type in HTTPS followed by the server IP and then the default Jupyter port. You will be presented with the Jupyter Lab interface in which you can upload your existing Jupyter notebooks, also open a new terminal, a Python file, Markdown file, and whatnot. To upload a Jupyter notebook, you can click on the upload button and select the Jupyter notebook of your choice. For example, I've just uploaded a new notebook for Stable Diffusion Excel. Now we can just click on it to open the notebook, and here you can see I can just click on play button to deploy the cells. Here we are just using Stable Diffusion Excel to create some AI generated art. So let's prompt it to create an image for astronaut in a jungle. And now that the image is generated, you can go to the cell below it and run it to view the generated image. And that's just how easy it is using the Vultr GPU stack. You can use the Jupyter Lab environment for uploading all of your existing IPython notebooks and running machine learning operations such as training a model, fine tuning a model, or even inferencing a model, just like we did in this example. Since it comes with pre installed PyTorch and TensorFlow, it saves you a lot of time for checking the compatibility and also setting up all the libraries. Apart from the Jupyter Lab environment, it also comes with pre-installed NVIDIA Container Toolkit, which means if you access the server using SSH, you'd be able to run containerized machine learning applications. You can also pull container images from the NVIDIA NGC catalog. For example, here I've prepared a Docker file which inherits Hugging Face's text generation inference image and configures it for Falcon 7 billion instruct model. We can see that by running docker image ls. I've already built this container image. Let's try to run this by typing in docker run. Let's demonize this so that it goes to the background. Let's proxy the port 8080 and provided access to all of our GPUs. Let's just quickly copy the name, paste it here, and by typing in docker container ls, we'd be able to see that the container is up and running. And then we can just copy one of these commands, which is just a curl request on localhost port 8080 endpoint generate with an input which says what is deep learning and a parameter which says max new tokens 20. I'm not sure if this will run, but it did, and we got a response from our container saying that deep learning is a branch of machine learning that uses artificial neural networks to train and make decisions. Let's try to tweak this with new parameters. Let's say max new tokens to 200, and let's ask it a different question. Let's try to ask, why should I migrate to Vultr? And let's see what the model has to say. Vultr offers a wide range of benefits, including high performance, low latency, a variety of data center locations, and additionally, Vultr offers a free trial so that you can test our services before committing to a long term contract. And that circles me back to Vultr Container Registry. So, a private container registry would be the perfect place to store images like the one we just created. To deploy a new container registry, you can come back to the customer portal, navigate back to products page, and click on container registry. Here you can click on add container registry, select the location and a name. Let's go with demo, um, or it might not be unique enough. So I'll just type in something like demo 123, select a location and a plan, which you can see here. We have a free tier for this for 10 gigabytes. So let's go with that, and we'll keep the visibility to private. Let's click on the add button, and that's how quickly you can get access to a private container registry. Click on this element and you will see all the credentials here and the command to log in with the Docker CLI. Here you can click on Docker slash Kubernetes, and you will see that you can generate Docker config JSON. You can just select this checkbox, click on generate config JSON. Home directory slash dot docker slash config dot JSON. Here is where you can put this JSON content, or if you don't save it, just like I did not, you can see the file is blank. We can just go back to the resource page and copy this command. There's just a docker login command with the username and password, and just like the config, this will create the configuration for you. Now that we have configured this, we should be able to pull a hello world container image, and then we can also give it a tag and then try to push it to our private container registry. Let's do exactly that. And now that we have changed the tag for hello world to SJC, which is Silicon Valley Vultr Container Registry.com, the name of our registry and the repository. This is the tag. You can have any number of tags, and then we can just copy the push command, run it here, and shortly, if you refresh this and go to repositories, it might take a minute. You can see that it has been pushed, but it is just a layer. So we'll just wait for a second. And now if we go back to repositories, you will see demo123 slash hello world. And now we can pull it from anywhere, from any virtual location, if we give the correct credentials. And just like that, we have easily uploaded our first container image to our private registry. You can go to the settings and also change the visibility if you decide to do so. You can also eventually upgrade the plan when you are done testing it to the higher plans with more storage. And that's about it. I hope that you liked the demonstration of Vultr GPU stack and the Vultr container registry. You can find the links to documentation for both of these products in the description box. Thank you so much for joining in. I hope to see you in the next one.